Hi students, now we are going to solve the problems in section B, which are 3 marks questions. Now question number 11th, A subdivision. It would cost a man rupees 3.50 to buy 1 kilowatt hour of electrical energy from the main electricity board. So you have to read the sentence again. What is given? The cost of 1 unit of electrical energy is given. So I am going to write first cost of 1 kilowatt hour, that is 1 unit. So this is equal to rupees 3.50. That is clearly given. His generator has a maximum power of 2 kilowatt. So the power of the generator, okay, power P is equal to 2 kilowatt. 2.0 means it is 2 only. Understand? So I will write 2 kilowatt. The generator produces energy at this maximum power, at this maximum power for 3 hours. So for how many hours the generator is running is 3 hours. So the time of running of the generator T is equal to 3 hours. Calculate how much it would cost. How much will be the electricity bill, that's all. So how much it would cost to buy the same amount of energy. You cannot go to electricity board and buy the energy and all. What does it mean? See, you have to understand the language here. That means find the electricity bill for the working of the generator for 3 hours. That is the question. Understand? So how much it would cost to buy the same amount of energy from the main electricity board. For this only 1 mark. For 1 mark, no, you should not waste much of the time. Okay, just you read, understand, and you substitute in the formula. So the electrical energy, we are going to find the electrical energy. So what is the expression for electrical energy? E, okay, or electrical energy is equal to power into time. So E, the electrical energy is equal to 2 kilowatt. 2 kilowatt multiplied by time is how much? 3 hours. So 2 into 3 is 6 kilowatt hour. So the electrical energy consumed by the generator is how much? 6 kilowatt hour. That means 6 units, is it not? So this is also equal to 6 units, commercial units. So what is the cost for 1 unit is given? 3 rupee 50 paise. So this is the cost of 1 unit. Therefore the cost of 6 units, the cost of 6 kilowatt hour is equal to 6 multiplied by 3.50. So this is equal to 18 plus 3. So 21 rupees. 21 rupees is the answer. This is the answer. How much easy it is, you see. So directly the question might have been asked in a different way. How they must have asked, what is kilowatt hour? Convert the kilowatt hour into joule. Like that they must have asked. Or they must have given the problem directly. What is the energy consumed by the generator when it runs for 3 hours and its power is 2000 watt. But here the English language, it plays a vital role. So my dear students, don't get upset by reading any problem. Try to understand and try to make a list of whatever quantity is given in the problem like this. Then your mind will definitely tell you what is the formula to be used. Is it not? Okay. I hope you must have understood well. Fine. Hi students. Now the 11th question, B subdivision. It carries 2 marks. A student boils water in an electric kettle for 20 minutes using the same mains supply. Here you have to read again. Using the same mains supply. What does it mean? the same voltage is applied for the second time also. Okay, students? So, using the same mains supply, he wants to reduce the boiling time of water. It's quite interesting problem, but difficult only for the first time when you read. So he wants to reduce the time of boiling, means he wants to reduce the time of flow of current. The time of flow of current in the first case you take 20 minutes, that is T1. In the second case, less than 20 minutes he wants to boil. So let us take as different timing, that is T2. So he wants to reduce the boiling time of water, means he wants to reduce the time of flow of current. So second time T2 must be less than the first time T1. That is the clue given here. Try to understand. To do so, should he increase or decrease the length of the heating element? So initially I will take the length of the heating element is L1. Okay. He passes some current or he applies some voltage across the heating coil, and the current flows for a time T1. In the second case, the current flows only for a shorter period T2. To produce the same heat, the resistance of the coil should be different. That is the idea to be used here. Okay, students? So justify your answer. So this question is not direct question. You must have expected state Joule's law, write Joule's law, or find the quantity of heat produced in a current carrying wire. Is it not? When current is given, resistance is given, time of flow is given, you can find easily. But this type of question also is quite interesting, and now we should take it as a challenge. Okay, students? So the situation is, first one coil is taken, its resistance is taken as R1. The length of the heating element is taken as L1, and the time of flow of current is taken as T1. So what will be the heat produced in the first coil? H1 is equal to V square by R into T. So the coil is having a resistance R1 and the time of flow of current is T1. Now, to produce the same heat but passing the current for a shorter period, reduce the boiling time. So for a shorter period T2 let us take, the heat produced in another coil, let us say H2. So this must be for the same voltage, because same main supply is mentioned, is it not? So for the same voltage, H2 must be equal to V square by R2 into T2. So this is the idea we are going to use to solve this problem. First we have to find out the relationship between the time T2 and the T1, because here the hint is he wants to reduce the boiling time, is it not? So in the second case T2 must be less than the first case T1. So T2 is less than T1. Second, we have to relate R2 in terms of R1. First we will relate that. So here to produce the same heat, okay, H1 is equal to H2. So V square by R1 into T1 must be equal to V square by R2 into T2. So cancelling this V square, we can write T1 by R1 is equal to T2 by R2. Okay. So T2 by T1. Now I will take T2 by T1 is equal to R2 by R1. Okay. So I will write here T2 by T1 is equal to R2 by R1. So T2 by T1 is equal to R2 by R1. So shall I write that T is proportional to R? Understand? So since T2 is less than T1, T2 is less than T1, is it not? Because he reduces the time of boiling of water. So the time of flow of current T2 must be less than T1. So if T2 is less than T1 means R2, okay, therefore R2 must be less than R1. So the resistance of the second coil must be less than the resistance of the, the resistance of the second coil is less than the resistance of the first coil, or R2 must be less than R1. Okay, what is the dependence of the resistance of a coil and its length, you tell me? Yes, the resistance is directly proportional to the length of the coil, is it not? So I will write, but R is proportional to L. Therefore, R2 is proportional to L2 and R1 is proportional to L1. Understand? Since R2 is less than R1, now L2 should be less than L1. Okay, hence L2 must be less than L1. Now you read the question once again. Should he increase or decrease the length of the heating element? Second coil's length is less than the first coil means should he decrease or not? Yes. Hence, okay, therefore he should decrease the length of the heating element. So this idea here, how many concepts are mixed together, you see. Joule's law is mixed here, is it not? Then the dependence of the resistance of a conductor on length is also clubbed here. So we cannot expect direct questions in the Cbse board examination in the term 2. So they want to test your knowledge and the understanding of the concept. So my dear students, practice such problems more. It is available in the Cbse website. I hope you must have understood this well. Fine.